Hello. In this video, we're going to look at converting a quadratic function from this general ax squared plus bx plus c form into what's called vertex form or HK form. And that is the form that you would use to identify the vertex or to do transformations on a quadratic graph. And so this first example we have is f of x equals 2x squared minus 8x plus 3. Now remember, we are going to have to use completing the square. And remember, with completing the square, this leading coefficient here has to be a 1. So our first step is we're going to factor out that 2. Now, we can't divide it like we did solving quadratic equations because on the other side, we've got an f of x or a y. And so we're really just working on one side here. So we're going to factor out that 2. The way that I suggest doing it is to factor it out of everything. So x squared minus 4x, and then 3, if we factor out a 2, is going to give us 3 halves. Now we want to complete the square, and remember when we're completing the square, we're only looking at those x terms. So I'm going to spread this out just a little bit. If we want to complete the square, we're going to have to add in a constant to complete that square. And then plus 3 halves. Now remember, in completing the square with quadratic equations, what we add to one side, we add to the other. Well, it's a little bit different when we're working on one side. Instead of adding it to both sides, what we're going to do is we're going to add it and we're going to subtract it. And we're doing this all inside the parentheses here because we want to make sure that this 2 is going to be multiplied by everything. All right, so when we complete the square, remember we take our b term, our coefficient on our linear term, our x term, divide it by 2, and square it. And that's what we're going to add to both sides. So negative 4 divided by 2 is negative 2, squared is 4. And when we So now what we're looking to do is factor what I have here outlined in red. So the factors of 4 that add to negative 4, that's going to be x minus 2, or x minus 2 squared. And then on the outside, we want to go ahead and combine those last two terms. So 3 halves minus 4. 4 is the same thing as 8 halves. So 3 minus 8 gives us negative 5 halves. And then our last step to get it in that vertex form, which remember is a times x minus h squared plus k, we're going to distribute that 2. So all we're going to do for this last step is to distribute the 2 to both of those pieces. Since we have that exponent, order of operations says we can't do anything until we expand that exponent, which we don't want to do. And then 2 times negative 5 halves is negative 5. And so that would be the standard form of our quadratic. All right, let's do one that has a negative coefficient. So same thing here. Our first step, we want to factor out that leading coefficient. So when we factor out this negative 3x squared, make sure that you remember to change the signs. That's going to give us an x squared minus 10x, and then 71 is a prime number, so 71 divided by 3 is not going to simplify. And if you want to go ahead and just leave it, even if it does simplify, go ahead and leave it, because remember, in the end, we're going to distribute it back out. So 71 divided by 3. Again, we want to complete the square for these first two terms. We're going to add and then subtract the same value. Here our b is negative 10, so negative 10 divided by 2, quantity squared. Negative 10 divided by 2 is a negative 5. Quantity squared is positive 25. And we're looking to factor these first three terms. So x squared minus 10x plus 25, the factors of 25 that add to negative 10 are negative 5 and negative 5. So that gives us x minus 5 squared. And then 25 is the same thing as 75 thirds. So 71 thirds minus 75 thirds is going to give us a negative 4 thirds. And then our last step, distribute that negative 3. So that's going to be x minus 5, negative 3 times x minus 5 quantity squared. And then negative 3 times negative 4 thirds is going to give us a positive 4.